Alright, so we're doing the derivative of this function here. Immediately I notice that the function's base is not e. So what you learned today, I would rewrite this as the natural log of the stuff divided by the natural log of the base. Now I would constant multiple roll out the the understood 1 over the natural log of 3. So 1 over the natural log of 3 is going to be multiplied, because I'm about to derive, just the derivative of everything else, which is 1 over the stuff times the derivative of the stuff. Parentheses, parentheses, and so on and so forth. My final answer, the way I would want you to write it on the test, because of what we talked about today of what goes where, would look like this, where the multiplication only occurred there. Cool?
Cool, very cool.
Alright, so here we go. Each orange circle will be 1 point. Each green, or 10 points, each green is 20. Okay? So 1, 2, 3, 4, 5, 6, 7.
Did you simplify it further?
How did you simplify that further?
Oh, maybe I did it wrong, but just so with the 2x plus 5 and the x squared plus 5x, I pulled out an x plus 5 from each.
No.
Okay.
You can't pull out an x plus 5 from each. No worries. Okay? So 1, 2, 3, 4, 5, 6, 7 is the most you could get.
We got all.
Nice.
All.
Nice. And then, Jordy, how many did you get?
I think we got the first 5.
Alright, so resuming the video, we are looking at number 6 and 7 on supplemental. And the derivative of this, when I see logs and natural logs, I immediately try to see if I can break it up with the laws of logs. But I can't on this, because remember, I can only break it up if that was multiplication. Okay? So I'm going to leave it as is, and I'm not going to write natural log of 5 plus the natural log. I can't do that. So it'll be, the derivative is 1 over the stuff times the derivative of the stuff. That means the original stuff's derivative. Okay? So that's 0, which we don't have to write. Carbon copy times the natural log of the base, which is just 1, we don't have to write that, times the derivative of the power. So e to the 4x times 4, I would want you to write that like this. Okay, instead of this. And we've talked about that with like listing out the constants first, the functions, and then the trigonometric, and so on and so forth. So between the power functions and trigonometric, now you have the exponential and the logarithmic. Do the e's first, alphabetical order, do the natural logs next. Okay. So I would look at this as 4e to the 4x over 5 plus e to the 4x. This would be the derivative. Now, I'm about to show you something right now that will help you for other problems. Well, actually, you know what? Let me just, it's in number 7. You're going to see it with number 7. 7's derivative is, this is an exponential function. So it's going to be the carbon copy times the natural log of the base times the derivative of the power. Do you think I want you to move this 2 in front? Yes or no? Or leave the 2 where it's at? I want you to move it. I want you to move it. Otherwise, it's going to be like natural log of 10, the way it's written. So, if I move this 2 up front, okay, and if I were to further simplify, how else could you simplify from here?
The 2 multiplied to 5.
That's the question. That's the million-dollar question that I'm trying to get to. Does this become 2 to the power of 2x? No, it does not.
Shoot.
It does not, because PEMDAS says if you have something written like 2 times 5 to the 2x, what PEMDAS is saying is do the exponent first, then multiply the 2. Not the other way around of trying to multiply the 2 and the 5 and then raise that to 2x. That's totally different. So I hope that you would write this. Because of that, I really wouldn't want you to put the 2 out front, but if you did, no worries. You could write it like this. But more than likely, that's not what I'm going to give you points for, simplifying it bonus point wise. Can someone tell me what I would give bonus points for?
Natural log of 25.
There you go. 5 to the 2x times the natural log of 5 squared. That's what I'm looking for complete simplification. Okay, ready? Here we go. 1 over the stuff, then bam, 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 bam. Remember the green is 20. And then we'll come over here. So 10, 20, 30, 40. If you wrote it and rewrote it to this, please give yourself 20 points. If you rewrote it all the way to this, so you're either going to give yourself 20 or 50, not both. Okay? So what? 1, 2, 3, 4, 5, 6, 7, 80 for the first one. 1, 2, 3, 4, 5, 6, 60 or 90. So if it's perfect, you either got 140 or you got 170.
It's just one person up to have
Any one of you, yeah.
We got 120.
120, 170, 110. Nice job. All right. Last problems for today. And the key will be posted whenever you're done. I'm going to do it on that thing that I can do it at the same time. I want you to do number 10 and number 11, and the answer will be waiting for you when you finish. But you have 5 minutes. Actually, I'll give you 6 minutes. 6 minutes. And the answer will be waiting for you. Resuming the video, we have y squared plus e to the xy minus e to the 3x equals 4. The first one is 2y dy dx. Then we have an exponential with a product rule inside. So it's the carbon copy times the natural log of the base times the derivative of this power. That's product rule. First times the derivative of the second plus the second times the derivative of the first, which is just 1. This last one is e to the 3x. Carbon copy times the natural log of the base times the derivative of power, and then equals 0. Look at this. This is very important. I need to distribute e to the xy to both x dy dx and y to get this down here. Notice that I put like the GCF here, not GCF, but I foiled or distributed this out so that I could get all of this right here. I GCF'd out the dy dx. I subtracted this to the other side. I added this to the other side, and then divided by this right here. Okay? So, with all of this being said, So here's 1, 2, 3, 4, 5, 6, 7, 8. If you did this distribution to get these two pieces, I want you to give yourself 20 points for that.
Yeah, I was gonna ask if you had to distribute it.
Yeah, you have to. And then over here, we'll say this is 20, this is 20, and this is 10. So each green is 20, each orange is 10. I'm just wanting to show you good work so you know what you're going to be expected to do test-wise.